unless it went through like different literary skills. Like, yeah, you got more complex as you went.
Do we have any math homework today?
We do. Number 6 through 11.
Yay, math homework.
Not too bad. And we will probably get to starting that here today in class. This is a quicker lesson. I thought about doing 2 lessons today, but because we're the first day back, we're not going to worry about that. I do need to talk to you guys about a couple things that some of you guys are doing really well, and some of you guys really need to work on, which comes down to heading and detailing your assignments or classwork or anything else. Some of you have very little system of organization aside from what number of problem are you on. So as we move forward, I do more frequent math journal checks because I realize some of you guys need it. I don't like putting a lot of pressure on you guys. I really don't. I say I'm here to make your life easy, and I truly believe that, like easier, teach you things that will make your life better and easier. But I think some of you need a little bit of pressure to promote these positive habits. So what we need to get in the habit of doing is when we're taking notes, notes get headed with the topic number and what it is.
I do that. I don't do that on
Special, right? Triangles. Yes, today is actually special right triangle. 611. Everything should be dated. Wherever you put the date, I don't care. Some people go top right corner, some people go top left. Some people go middle. I don't care. It just needs to be on there so you know when you did it. Yeah, middle, right? Who means middle?
Middle of the page.
Middle. Dead center.
Right. Dead center in all caps.
I mean, if you did that every day, I guess it could be like you. And then homeworks. Hey, this is what a lot of people need to work on because we're going to start to check things more and more because second semester we get into some harder content that I need to make sure you're actually doing the homework as we go. First semester I was less worried about that because a decent amount of it was review/extension. Homework assignments. If I was going to go to do tonight's homework and you could head a paper for it now, some of you I know you have binders where it's like, here's my notes and then here's my homework. You can start the header now. You want to label it either homework or you could say practice if you'd rather call it practice. My kids argue it's not homework because I don't do it at home. But it's homework 611, numbers 6 through 11. That needs to be on your paper. You need to identify that it's homework or practice or not classwork. And you need to have on there what the assignment is. Some of you, I think, are choosing not to do that. Or are just not doing it, whether you chose or not. And then utilizing that as an excuse or a way out to not complete the assignment. So if the assignment starts on question 6 and you do 6 through 9 and then you stop and you don't have anything on your paper saying that the assignment was actually supposed to be 6 through 11, well then who knows that you didn't finish. You might not even know that you didn't finish. And you might not, like if I do like this and it's like pick 4 or pick, and you don't write that down, and you're not sure, like, what was the assignment? What actually is this? So we need to have headers that have all that information. Okay, what it is, whether it's notes or practice. Notes don't have to have a header aside from the topic. You could write notes if you want. You don't have to. Homework, practice work, whatever you want to call that, has to have an identifier. Okay, things have to have headers. And names. If it's going to get turned in, now if it's a packet, if it's stapled, if it's in your notebook still, that's okay, as long as there's one name on it. Now, moving forward, be careful with that because there's a top page rips option. But with me, we're a small enough class, that's not really dangerous. Yeah, things I need to know that.
What if we have it in a special section?
I mean, if it's all still together, or if it's like in a binder or something, that's okay. But when you go to turn it in, you got to make sure it has a name.
But like, do we need to put practice on our homework if we put it in like?
You need to have a header on your homework. So even if you don't put this, you would need to have this part of it. Yeah. So even if you don't have homework, right, if it's in the homework section of your binder, you would then just need to have like 611, number 6 through 8. Because the notes every day are never going to be number to number. It's always a topic, and we just get how far we get. Any questions? We wanted to kind of reset and restart as we go into quarter 3 to make sure that as I start to get more critical with this grading, it's not harder for you guys. It just keeps you kind of up, achieving where you should be. Some of you guys are just slacking because I let you get away with it, so my apologies. I should have a little bit more pressure. All right, moving on into the lesson today. So special right triangles. We know about special right triangles. We should already a little bit. there are two that we like to talk about, right? Or two main ones. And remember what they are? The 30, 60, 90, and yeah, 45, 45, 90, right? So the isosceles right triangle, 45, 45, 90, and the 30, 60, 90 special right triangle. This is why I said today's lesson is going to be quicker. Because we've already talked about these in Math 1, we need to remember these things, extend it a little bit, and then we'll do some practice. So, hopefully we have a header on our notes. You can make it as fancy as you want.
Wow.
So, Darren wants to determine unknown lengths in this triangle. The only thing we know is that we have a hypotenuse of 2, and it's a 30, 60, 90. So, Jan, a teammate, says, well, we can just do this, just reflect it. And Darren's like, all right, why? What's the point? So make a quick sketch of this on your paper. Show why Jan is doing what she's doing, and how that's going to help us determine any missing lines. One's not drawn perfectly. Yeah, why did Jan tell Darren to reflect the triangle? And then we make an equilateral. So because I know that I have 60 there, and then I will have 60 here, and then two angles of 30 at the top makes 60. I've got equilateral. What good does that do for us? You know? Go ahead.
All sides are the same.
All sides. Now, what does that help us solve? A or B? It gets us to A really easy, right? Because if we see that this, what we now know is double A, is the same as the hypotenuse we've been given, then A is going to be 1, or if we make a general rule for this, the short leg, so let's write out a general rule. So label somewhere that we're talking 30, 60, 90 rules, right? So 30, 60, 90, or if your picture suffices or whatever you need. So in a 30, 60, 90, the short leg is what? How could we make a rule for this?
The short leg is half of the hypotenuse.
Half the hypotenuse. Now solve for B and try to figure out, is there any rule that we can make? You might remember it. If you just got it stored back in there, that memory, you might remember this. You might not, though, so you might need to use some other math, some algebra. You might actually need to solve it with a calculator. So take a moment, solve for B. When given two sides of a right triangle, what will always work? Pythagorean, right? So always we can do Pythagorean. If we had coordinates, we could do distance formula or things like that, but we can do Pythagorean, right? So we can say my a squared, which literally here is labeled a and b. So 1 squared plus b squared will equal 2 squared. Right, we set up our Pythagorean, which we just end up with 1, okay, great, plus b squared equals 4. So then b squared equals 3. So then b is
1.73.
square root of 3. Interesting.
Leave it in exact form.
I
Oh, wait, we
would
did
leave
do
it in
this.
exact form.
We did
I
do this.
would. I totally agree. Leave it in radical form.
We did this. I remember now.
So it's totally fine if you don't. It's,
But I
you,
don't
you
remember
aren't
what
meant
it is.
to
I don't
just
remember the
know
root, but
this.
I remember the square root of 3.
So radical 3 comes back up. And one thing I want to point out right now, radical 3 happens in the 30-degree situation. When there's the 30 degree, we're going to involve a radical 3. Now this is with right triangle, right? So we know we've got 30 and 90. The other one has to be 60. Right? So when we say 30, 60, 90, it's kind of redundant since we're talking about right. Hmm?
What if we have 40 and 50?
That's not special right. So the two special rights that we talk about that have easy rules to work with. Now we could look at 40, 50, see can we make any rules. The reason this works is 30 is half of 60. Right? So if I clone my triangle and reflect it, I can make an equilateral. As opposed to a 40, 50, that doesn't really work. Right? So that would be awkward on that. But in a 30, 60, 90 triangle, the way I, in high school, was able to remember which goes with which, 3, 3. 30 degree, radical 3. Now here's the question. What if A is not 1? Which then also means what if the hypotenuse isn't 2? So what if we played this situation out, but instead of having a hypotenuse of 2, let's have, I think they say 7. Right? 7. I'm skipping around. Go figure. What if we just double in size? This will make our life easy. So, going rogue from the book, but what if that was actually 4? What else would we know? A is 2. Okay. So if I come over here, well, my Pythagorean would totally change. So think that up through. Solve that for a minute and tell me what B would be.
2 times 3.
Well, we get to the point of B squared being what?
Root 12 or 2 times root 30.
So we have like 16 equals 2 squared plus B squared. Right? So 12, you said is how we got there. Or Koppel said, this is really, why do you keep doing this? My smart board is not very smart these days. Koppel says 2 root 3, because we can break this up into radical of 4 times 3. And that's how the 2 comes out. Okay. So we had root 3 for the first one. Now we have 2 root 3. What if, still thinking back to our original triangle situation there, I had 6 for my hypotenuse. Sorry, that's not drawn very well, but let's assume this is still a 30, 60, 90. Draw this a little bit better.
What if it's 3?
Yeah, your short leg is still 3 because we already made the rule, right? Because it's half because, excuse me, we could reflect. We know that that short leg is half the hypotenuse.
Yeah, would you say
Would it be 3 root 3? Which if I work backwards would mean this would have to have been root
Wait.
27, right? Because square the 3 to come in, that'd be 9 times 3.
And then, yeah. But, so, the multiplier of the square radical 3 is from the short.
So what's your
That's
idea?
it. So do you?
That's an observation.
Yeah. But do you take the radical 3 and then use the length of the shortest leg and then you multiply radical 3 by that?
The long leg in your special right triangle is always radical 3 times the short leg. And the short leg is always half your hypotenuse. So we've got a very easy way to save us from having to do work if we can remember these two rules. Now, if these mental tricks help you, great. If they don't, forget them. The way I always remembered the half relationship, jumped right on my hands. That half relationship, 30 is half of 60. Now, don't relate short side as half of long, because that's not, don't think about the angle. But in this situation, I have a relationship that is double and another relationship that is double or half or anything you see there. So radical 3, I always remember because, well, the 30. Half because 30 is half of 60. Any questions? Short legs half hypotenuse, long legs rad 3 of short leg. So, moving on, what if, I'm clearing this, we look at a situation like this. So check out this 30, 60, 90. Try to solve that real quickly.
Wait, are we doing A or?
This triangle. I don't really care which part we're really on B, I guess. So now we're on 6-2. But we're kind of skipping through this because all we're doing is getting some of these rules and testing. Yeah. So we could talk. Some of this stuff we skip past because this is written for the regular level students. If we needed to defend why this always works, we could show with different sizes, different dilations, the reflection will always hold true to make the base of the now isosceles triangle the same as the hypotenuse, or now equilateral the same as the hypotenuse. We cut it in half. We show that that always works, right? So it's just proving that that rule will hold. Remember to check if it's drawn correctly. Sometimes it will look different than what it's actually showing, or like what it's telling you. So I'm going to draw this in a different manner, but still 30. Then across from my 30 is the y. My hypotenuse is 8. My long leg across from the 60 is x. So, Gunnar, can you tell me anything there? Y will be 4. And Jenny, what else do we have? So what part of the triangle is x? Ask yourself, is it short leg, long leg, hypotenuse? Long leg, right? Long leg relates to, does it relate to the short leg, right? How does it relate?
Oh, right.
Close.
Wait, no.
These have the double relationship.
That's multiplied by square root.
So we're going to have 4 radical 3. Now, we could do the algebra. We could do Pythagorean theorem. That will always work, right? Pythagorean will always work. But we don't need to. This is why they're special right triangles. Not because your mom likes to say that you're special, but really, this situation lets us skip over work. And there's another one that makes life, well, I don't know if I'd say even easier. Depends on how you think, but real easy. Any questions on this? What about the vertical of that triangle?
7.
Ethan?
That wouldn't work. 3 is not half of 7.
So what do you mean that wouldn't work?
Well, you can't use the 30, 60, 90 because it's not a 30, 60, 90.
Ah, it's not a 30, 60, 90. We can't solve that vertical so easy because they give us 7 and 3. If you immediately try to dive into this and say, oh yeah, it's a 30, 60. No, it's not. Check it. It's not 30, 60, 90. It's not special. Sorry, Mr. Right Triangle. You're just made with prime numbers, and you're just you. Okay, we could solve this, but then we're going to have to use Pythagorean or something else, right? We can't use the special right triangle unless it fits into our special right triangle category. Yeah, well, we're transferring data. Not, those don't charge from that, at least I don't think.
Transferring data.
Yeah, so you could like write a code on your calculator and transfer it to somebody else's.
That's cool.
All right, so now Darren decides if they don't all work in 30, 60, 90 form, let's look at one that is just obviously not, right? So check out this triangle that Darren's got now. How are we going to help Darren
We're gonna find out
solve these ones?
new rules for a 45, 45, 90 triangle.
We're going to find new rules.
Woo!
The rule is.
All right, work with your partner for a minute. Let me know what you guys figure out.
Hello,
Hey,
partner.
hello,
How's it
partner.
going?
Hey, partner. Hello,
This
partner.
partner.
Right.
Look, I told you guys when you came in, you're going to have to work with each other. It's hard to find a job where you just get to work by yourself.
Oh, no, we know that. Are you, oh, wait, here. No, I mean, I thought that. Yeah, so we know that A and 1 same. 8 is 1, and then B is squared. Yes, that's obviously what I said. I said the whole song.
Okay, so
Did you guys share that with your family over break?
Oh, yes.
Not at all. They don't need to be
I
bothered
did it
down by
before
that.
break.
So let's say you didn't like put it on at the holiday party.
Figure out.
I know.
Just to clarify, people, my parents aren't going to disagree.
I know that the triangle is.
So I heard from most groups that we immediately know A is 1 also, right? And I should really draw that from somewhere else. And then to solve B, we can use the Pythagorean. And when we use the Pythagorean, what do we get for B? Root 2. What if we dilate this? Right? And we know some rules about dilations. But what if my vertical, or one of my legs, it doesn't really matter. Now we can just call A leg, because we know it's isosceles. What if one of my legs is now 20? Bless you. Well, then this, yeah, is going to be 20. But then if I think about A squared plus B squared, okay, so I have 400 plus 400, right? 800 equals C squared. So here my hypotenuse squared 800, so I square root that. What do you mean it's so much easier than this? Well, what? Okay, share, please.
You can do the hypotenuse of 2, I mean, wait, you can radical of 2 of the root.
Wait.
What do you mean? Why?
2 times the root was in radical.
Why?
I don't know.
You're right, but we need to know why. Why can we do that? We've not made a rule, but I can see mathematically how you got from where we were to here,
Wait.
and how you got. But why?
I forget.
So what Ryan is saying is to find C, we can really just radical 2 times, let's say, I guess A. We can call our leg, since we were working with A as our leg in the other one. Would that have worked? Right here?
Yeah.
And what do we know about when we dilate shapes? the ratios must be equal. Right? So if I take hypotenuse compared to leg, I have hypotenuse compared to leg, and what happens to my leg is a multiplication by 20. What happens to my hypotenuse? A multiplication by 20, keeping this square root of 2 involved in the situation. So now, we have square root of 3 when dealing with a 30, 60, 90. Now we're going to say square root of 2 is involved in a 45, 45. So we're going to, let's hypothesize here. Let's make a hopeful guess that in a 45, 45, 90. So go ahead and document somewhere that we're talking 45, 45, 90. The hypotenuse, according to Ryan, is going to be radical 2 times the short leg. Or you can flip that around and say like short leg times radical 2 because it's kind of nicer that way. You guys want to know how I remember that one?
Is there two 45s?
Because there are two 45s. We use radical 2 because there's two identical angles.
Well, you can also remember the 3 because all of the
Three
angles
different angles.
they can be factored by that.
Yeah.
330.
Now, if that rule is going to work, which we know with fair certainty it is mathematically sound, what would the hypotenuse in triangle 2 be?
Oh, it's 5 squared.
5 square root of 2.
I already saw that. 7 going.
Question. What would happen if I reflect this like we did with the 30, 60, 90? So that made previously an equilateral right triangle, right?
Wait, you can make a square. Wait, you can make a square with it. If you reflect it. Yeah, you reflect across the hypotenuse.
If we reflect across the hypotenuse, we can make a square, and then what we have for the hypotenuse is the diagonal of the square.
Yeah.
What if we reflect across this way?
You get a B this.
Colin?
You get a bigger,
Not equilateral.
bigger isosceles.
A bigger isosceles, 45, 40.
And
You just
get
end up
index
doubling.
Going along one of the short sides, and you just getting like exponentially bigger and bigger and bigger.
It's like one of those paper footballs. You start with a triangle, fold it into another triangle, fold it into another triangle, but here we'd be like unfolding into bigger and bigger triangles.
It's cool.
All right, perfect. Moving on.
What the
Practice. 6-4. Take 3 minutes, 30 seconds each. Then we'll check these and we'll move on with life. gives you the hypotenuse. Leave your answers in exact form. Why are you making a face at that one? I know why, but I want you to articulate it.
How do you find out what the square root of 3, square root of 3 times 1 is 6?
So you're saying this is square root of 3 times something, right?
Yeah.
How do you solve for that something? Leave your answer in exact form.
Oh.
In A, do they give us short leg, long leg, hypotenuse? Short leg. So what is the long leg? What's the long leg? The long leg? Yeah. Hypotenuse is 20, right? This is 10 radical 3. Sorry, people are like really, really timid. Right? So 30 degrees radical 3. A 30-degree radical 3. Radical 3 times our short leg. We're given the short leg, so we can find both radical 3 or double. 45, 45. Radical 2, not radical 3. They give us short leg, so they give us both legs, really. Yeah, and they give us equal leg. Thank you. I was waiting for somebody to hear that and be like, well, short leg is long leg. And hypotenuse? Yeah, 4 radical 2.
Sorry.
8, 8, 8, 8, 8, 8, 8. Sorry, that's an 8. Now, be careful. D is one of those situations where it doesn't quite look how it should. Right? It's a 30, 60, 90. Does it look like it?
Oh, crap. But it
See?
is.
So, it looks like a 45, 45. Is this unknown short leg or long leg?
That's the short.
This is short leg, which will be half of, oh crap.
What?
So wait, how do we solve this?
Well, I mean, we know the property of the relationship between short leg and long leg, so just reverse it.
Okay, so if we know the relationship between short leg and long leg, we can take it backwards. Chris?
So the first thing I did was make the 9 radical to radical 81.
Okay.
Then divided by, since you would have to multiply by radical 30 to get that, you would just divide by the radical 30 to get that.
But if we know that the other side is the short leg, and that means that 9 has to be the long leg, so you just take half of 9 and just multiply. Right?
So what Chris is saying, so short leg's half of hypotenuse.
Okay.
Be careful, they gave us long leg. So Chris is saying we know long leg is radical 3 times the short leg. Right? We're trying to solve for the short leg. For a radical times something to equal just a radical, this should be a radical, right? Because then they can combine. We're kind of working backwards from when we break them up and try to get them to reduce out. So what do you say A is, Chris?
Radical 27.
Because 3 times 27 make 81, but everything's got to be radical. The mistake people will make here is try to just say this is 27. It's got to be a radical value to combine to make one radical. So A has to be radical 27, which can actually be simplified. 3 radical 3?
Yeah. Good job.
How does that help us solve the hypotenuse?
Oh, we know that the height is the 2 times.
So if the hypotenuse is double the short leg,
Then it's 3 radical 3.
we have 3 radical 3.
2 times.
Oh, 2 times. So what does that come out to be? This is what I'm checking, your multiplication. What is it? 6 radical 3. I just wanted to make sure we didn't try to do anything with the radical 3. We double it, just double that coefficient. It's like taking a 3x and double them, you get 6x. Don't mess with that radical 3. This is what Ava and I were talking about. If we know that the hypotenuse is radical 3 times the short leg, then we could write that out. Radical 3 times the short leg equals what we have for the hypotenuse. We can then work it backwards. Yeah. We can then work it backwards to get A. You shouldn't need a pass. I hope they don't ask you for it. Just tell them I had to just send you. How do we get A by itself?
You divide it by square root of 3.
We divide here. So now, is that going to give a short leg, long leg?
That's gonna get
Short leg, right? Because that's what relates to the hypotenuse. Short leg will be 6 divided by radical 3. Hypotenuse is double the short leg. Or sorry, radical 3 times your short leg. So then, long leg
is 6 over 3 times 2. No, it's not. Is it? No, it's not. It's not. Definitely not.
Is that your final answer?
Yes.
So wait, I'm confused.
Is it? Or
Oh, it's 6 times radical 3 times radical.
Who what?
I don't know.
over radical 3 times radical
What's our
3?
rules again?
Well, isn't the rule for the long leg, which is what we're trying to find now, the short leg times radical 3, so it would be 6 over radical 3 times radical 3.
Yeah.
Did the rule that we
it's
wrote
6 over
down
radical
here
3
for...
times
So wait, our hypotenuse rule that we wrote down here, is that right?
Yeah.
What is that solving for? Radical 3.
That's solving the short leg. No, I don't know what I'm saying. Or what we're doing.
Other side. Where did our rules? Did I erase the rules?
I have the rules.
For 36 90, the short leg is 1/2.
No, that's for the hypotenuse. The hypotenuse is
I'm just listing
with,
how to. Wait, didn't we use?
no, with the hypotenuse, with the 6 over the square root of 3, we're solving for the short leg, and we're now trying to solve for the long leg, and that's the equation for the long leg. So it's 6 over radical 3 times radical 3.
We solved for the long leg.
Why?
Not because that we just looked at it wrong. I was waiting for us to figure this out and catch it.
You did?
This equation, the radical 3 relates to the long leg.
So we used the.
Okay, so over here, a few slides later, we put this. I was paying. Who's paying attention? This is
I'm
the
paying
long
attention.
leg. Okay, this is why it didn't work, right? We got in this. Wait, we gotta. No, wait. What? We put something in the wrong place. Occasionally, I have to throw these in here to see who's paying attention, who can catch it. This is not short leg; it's long leg.
So
Short
it's
leg
just 3.
relates how? It's just 3.
Okay.
Okay.
Is this why you
Now, wait a minute.
Is this
Now,
why
wait,
you were
wait,
trying
wait,
not to
wait,
smile the
wait.
entire time?
So this, we got to be really careful using A and things like that now. So I'm actually going to delete this and take us back a moment. We said short leg's half, right? So now we can easily determine short leg here is 3. How's long leg relate?
The short leg times square root of 3.
Short leg times radical 3. So this isn't 3 or whatever we had before, radical 6 or whatever. Yeah, this is 3 radical 3.
We made that way too fast.
Because, hey, here's what I'm trying to emphasize. We misremembered one rule. We goofed up one rule, screwed up the whole thing. Okay? You gotta practice this for the rules to really get ingrained. Short legs, half the hypotenuse. That's the easy connection. Long leg involves the radical 3. Radical 3 times the short. And then here, what are our legs?
Oh, they're 6 over radical 2.
Yeah, 6 divided by radical 2. Because that one we do have to work it backwards, since this is radical 2 times our leg. Alright, we're out of time. That's all we got. Sorry we did not get to any of your homework, but it's only like 5 questions, so you guys should be fine. Thank you very much. Have a wonderful day. 3 years. It takes 3 years, I quit.
In a calculus class. How do I do this?